In the vast, silent theater of the cosmos, two of humanity's greatest creations are in the spotlight. In one corner, the veteran champion, the telescope that became a household name and defined our vision of the universe for a generation. In the other, the revolutionary newcomer, a golden-eyed giant promising to show us the very beginning of time itself. It's a symbol of our unrelenting curiosity. Then, in 2021, a new titan arrived. The James Webb Space Telescope, or jwst, launched with the monumental task of succeeding a legend. It's bigger, more powerful, and it sees the universe in a fundamentally different way. This is the story of the Hubble Space Telescope versus the James Webb Space Telescope. Is it the venerable pioneer that showed us the universe in all its visible glory, or the technological marvel built to see what has, until now, remained invisible? This isn't just a comparison of machines, it's a clash of legacies, of different ways of seeing, and of two profound stories about our place in the cosmos. Let's break down the tech, the breathtaking images, and the groundbreaking science to find out who really wins the quest for the stars. For more than 30 years, Hubble has been our window to the universe, delivering images that are not just scientifically profound, but culturally iconic. So, a cosmic debate was born. Who is the true king of space exploration? Remember the pillars of creation, that iconic stellar nursery Hubble made famous in 1995. For years, it was the pinnacle of cosmic photography, a breathtaking landscape of gas and dust where stars are born. Now, picture that same region, but seen through a new set of eyes. Suddenly, the obscuring dust becomes translucent, and inside those majestic pillars, hundreds of newly formed, fiery red stars blaze into view for the very first time. That shocking reveal, that power to peel back the layers of the universe, is the magic of the James Webb Space Telescope. It's a moment that perfectly captures the essence of this showdown. Two of our most powerful eyes on the universe are in a cosmic face-off, but who truly wins the epic quest for the stars? The weapons of a titan. To understand this battle, you first have to understand the hardware. At a glance, Hubble and Webb might seem similar. They're both just telescopes in space, right? But their designs, their abilities, and even where they hang out are fundamentally different, and that's what decides what they can see. In astronomy, size is everything. A telescope's primary mirror is like a light bucket. The bigger the bucket, the more light it can collect. The more light you collect, the fainter and more distant the objects you can see. Hubble's primary mirror is a respectable 2.4 meters, or about 8 feet, across. For its time, it was an engineering marvel. But Webb's mirror is in another league entirely. Made of 18 hexagonal, gold-coated beryllium segments, it unfolds in space to a staggering 6.5 meters, or 21 feet, in diameter. This gives Webb over 6 times the light collecting area of Hubble. Star-forming regions, the centers of galaxies, and the dusty disks where new worlds are born, are all shrouded in mystery for Hubble. For Webb, those same regions become transparent, revealing the fiery processes happening inside. This isn't just a small step up. It's a revolutionary leap that allows Webb to see objects significantly fainter than what Hubble can. Infrared is just heat radiation, so, if the telescope itself were warm, it would be blinded by its own glow, like trying to photograph a candle in broad daylight. This brings us to their next big difference. Location. Hubble orbits the Earth just 515 kilometers up. It orbits the Sun 1.5 million kilometers, or about 930,000 miles, away from Earth at a special gravitational balance point called L2. At this lonely outpost, it uses a massive 5-layer sun shield, the size of a tennis court, to block heat from the sun. This keeps Webb at a frigid minus 220 degrees Celsius, making it sensitive enough to detect the faint heat of a bumblebee on the moon. This extreme engineering is the price of its power. No human has ever gone that far, so if something on Webb breaks, it can't be fixed. It had to work perfectly, right out of the box. This proximity had a huge advantage. Astronauts visited it 5 times to fix a famous mirror flaw and upgrade its instruments over the years. Hubble is the versatile, serviceable veteran of low Earth orbit, a master of the visible universe. Webb is the larger, colder, more distant successor, a specialized infrared powerhouse built to see farther and deeper than ever before. The technological edge undeniably goes to Webb, but tech is only as good as the pictures it takes. The real game changer is what kind of light each telescope sees. Hubble is an expert in visible and ultraviolet light, the same kind our eyes can see. Why infrared? 2 critical reasons. First, the universe is expanding. As light from the most ancient, distant galaxies travels across billions of light years to reach us, its wavelength gets stretched out, shifting from visible light into the infrared spectrum. This is called RIP. To see the very first stars and galaxies that formed after the Big Bang, you have to look in the infrared. Hubble can see a tiny bit of near-infrared light, but Webb's vision goes far deeper into the mid, letting it peer back over 13.5 billion years into the cosmic dawn. This is why its images, like the iconic Hubble Deep Field, feel so intuitive and stunning to us. It showed us the universe in colors we could recognize. Let's start with the most obvious difference, the mirror. But a bigger mirror is only part of the story. Webb, however, is an infrared specialist. It's designed to see light that's invisible to the human eye, light that we feel as heat. Second, infrared light has a magical ability. It can pass right through the immense clouds of cosmic gas and dust that block visible light. To be this sensitive to infrared, Webb has to be incredibly cold. Webb has no such safety net. So in round one, the tale of the tape is clear. The view from the front line specs are one thing. The proof is in the pictures. This is where the cosmic battle becomes a breathtaking art show. And when we put images from Hubble and Webb side by side, we aren't just seeing better photos. We're seeing the universe in a whole new light. Let's go back to the pillars of creation. Hubble's 1995 image was majestic, showing massive columns of gas and dust in the Eagle Nebula, 6,500 light-years away. It captured imaginations worldwide. When Webb turned its golden eye to the same spot, the result was a revelation. In Webb's infrared view, the pillars, which seemed opaque to Hubble, become semi. Hubble's image is a magnificent family portrait, showing 4 of the galaxies locked in a slow, cosmic dance. It pushed our view back to about 13.4 billion years ago. Webb was built to shatter that record. In its first deep field, Webb did what Hubble did, but faster and deeper. Using its powerful mirror and infrared sight, it captured thousands of galaxies in a single shot, some existing just a few 100 million years after the Big Bang. These are the faintest, readest, most distant galaxies ever seen, the ancestors of our own Milky Way. But Webb's view is a dramatic, violent, epic. Its infrared vision cuts through the galactic dust to reveal shockwaves and tidal tales of gas being ripped from the galaxies as they collide. While Hubble's images are historic and beautiful, Webb's views are a leap into a new reality. They don't just replace Hubble's work, they add a new dimension. By combining Hubble's visible light with Webb's infrared, scientists create the most complete views of the universe ever. It's teamwork. Most spectacularly, Webb directly imaged the light from material swirling around the supermassive black hole at the center of one galaxy, revealing a brilliant, active core that was previously hidden. It's the difference between seeing a photograph of a storm and being inside the hurricane. The thick dust is pierced, and we suddenly see what was hidden. Countless newborn stars, glowing like red embers inside their dusty cocoons. Webb didn't just take a prettier picture. It transformed a beautiful landscape into a dynamic, active stellar nursery, revealing how these infant suns are actively sculpting the pillars from within. Hubble's view of the cosmic cliffs is stunning, showing how radiation from hot, young stars carves out a cavern in a wall of gas. It's beautiful, almost ethereal. Webb's image of the same region is overwhelming. What looked like a smooth wall to Hubble is resolved by Webb into a jagged, three-dimensional landscape of mountains and valleys. Its infrared vision reveals hundreds of previously hidden stars and even background galaxies shining through the nebula. You feel like you could fly through those cosmic canyons. Then there's Stephan's Quintet, a group of 5 galaxies. Perhaps the most compelling comparison comes from the Carina Nebula. And what about deep space? Hubble made history with its deep field images, staring at a tiny, seemingly empty patch of sky to reveal thousands of galaxies. In this round, the verdict is clear. The stories they tell beyond the stunning images. The ultimate measure of a telescope's greatness is the science it produces, the fundamental questions it helps us answer. Here, Hubble and Webb showcase their distinct, yet complementary, genius. For 35 years, it has been a relentless discovery machine. It was Hubble that provided crucial evidence for the accelerating expansion of the universe, a shocking discovery that led to the concept of dark energy and earned a Nobel Prize. It helped pin down the age of the universe to about 13.7 billion years with incredible accuracy. Hubble charted how galaxies evolve, confirmed supermassive black holes at the center of most large galaxies, and was one of the first telescopes to study the atmospheres of exoplanets. Its discoveries are the bedrock of modern cosmology. For years, a cosmic puzzle known as the Hubble tension has baffled astronomers. Measurements of the universe's expansion rate using the early universe. Isaac Newton famously said, "If I have seen further, it is by standing on the shoulders of giants." Webb is the embodiment of this. It's not replacing Hubble. It's building on its monumental legacy. Hubble mapped the modern universe, and Webb is now exploring its ancient history. Together, they give us a complete picture of cosmic events. Didn't agree with measurements from the modern universe. This discrepancy could have pointed to brand new physics. The first step was to double-check the math. Webb was tasked with reobserving Hubble's targets. The result: new data from both Webb and Hubble have brought the measurements into statistical agreement, suggesting the tension may be resolved and that our standard model of the universe holds up. For now, Hubble's legacy is nothing short of revolutionary. It rewrote textbooks. Webb's prime directive is exploring the early universe. It's a cosmic archaeologist, digging back in time to witness the first light from the very first stars. It has already found galaxies existing just 280 to 300 million years after the Big Bang, shattering old records. By studying these primordial galaxies, Webb is writing the definitive history of how everything, including us, came to be. But every great story has chapters left unwritten, and that's where Webb comes in, designed to tackle the mysteries Hubble couldn't solve. It can search for water, methane, and other molecules that might be signs of life. And in June 2025, it hit a major milestone, the first ever discovery of a new exoplanet by using direct imaging, named TWA7b. This Saturn-mass world was photographed by Webb's ability to block the overwhelming glare of its parent star. This opens a new era in the search for habitable worlds. Another frontier Webb is conquering is While Hubble could peek at atmospheres, Webb's infrared sensitivity allows for a much deeper chemical analysis. But one of the most exciting stories is one they're writing together. So, in the science round, there's no loser. So, after this cosmic clash of titans, who really wins, James Webb or Hubble? The truth is, this was never really a fight. It was the story of a master passing the torch to a worthy successor, only to find that both are still needed in the race. For over 35 years, Hubble has been more than it's been a cultural phenomenon. It took astronomy from obscure journals and put it on the nightly news. We are living in a new golden age of astronomy, where these two incredible observatories are working at the same time, giving us a view of the universe with unparalleled breadth and depth. One gave us the grand map of the modern cosmos, while the other is filling in the mysterious, ancient territories at the very edge of time. So the final verdict is this: the true king of space exploration is on one telescope or the other. It's the powerful, complementary partnership. They represent a collaboration that keeps expanding our vision and deepening our wonder at this magnificent universe. It made explorers of us all. Its discoveries built the very foundation that made Webb both possible and necessary, and Hubble remains a vital tool. Its unique ability to see in ultraviolet light, perfectly complementing Webb's infrared expertise. To truly understand the cosmos, you need to see it in all its light, a job that requires both champions working as a team. What do you think is the most important discovery made by either telescope? And what do you hope they find next? Let us know in the comments below. And if you love exploring the biggest questions in the universe, make sure to subscribe and hit that notification bell, so you don't miss our next journey into the final frontier. Thanks for watching. To declare Webb the winner because its tech is better is to miss the point. Webb is undoubtedly more powerful. Its infrared vision sees deeper, and its discoveries are shedding profound light on our cosmic origins. It's the future of astronomy, pushing the boundaries of what we thought was possible by seeing the first galaxies and tasting the air of other worlds. But to discount Hubble would be to ignore the giant whose shoulders Webb stands upon. The real winner here isn't a single piece of hardware. The winner is us. Hubble taught us where we are in the universe. Webb is teaching us where we came from. The story of discovery is far from over, with both Hubble and Webb sending back new secrets from the cosmos every day.